Hi everyone and welcome to this lecture. So here we are going to talk about the main steps of the particle swarm optimization algorithm, the general structure of the algorithm, and next, in the next slide, the detailed steps of this algorithm. So let's get started. So these are the 5 main steps of this algorithm of particle swarm optimization. First, we have to initialize the population, the swarm, with random values, with random positions and velocities. We have to evaluate the fitness of every particle. We have to compare the value of each particle position with its previous position. And here, by doing this, we are going to find the personal best, or the p-best. Next, we have to build a list with these p-bests. And we have to compare these p-bests, these personal bests, to find the global best, or the g-best, which is the best position of the swarm. Next, we have to update the velocity and the position of every particle of the swarm. These 4 main steps right here will be done repeatedly until a stopping criterion is met. This stopping criterion can be an adequate fitness value or a number of iterations. The number of iterations is more common. So here we have the detailed version of this algorithm, particle swarm optimization. First, we have to determine the fitness function, and the fitness function depends on the nature of the problem. We have to determine the hyperparameters, the inertia, which is also known as W, C1, which is the cognitive weight, and C2, which is the social weight. These are hyperparameters that usually range from 0 to 2. We have to initialize the particle population with each respective position. So we have to generate a random swarm in which each particle has a random position. So here we have a loop, which is the number of iterations. This can also be thought as a hyperparameter. For each particle, we will evaluate the best position. If the current position is better than the best position, then the best position is the current position. For the particle set, or the particle swarm, if the particle position is better than the best global position, then the best overall position is the particle position. And here we are going to update the position of every particle with this formula. The new velocity is given by inertia multiplied by velocity plus C1 multiplied by R1 multiplied by the difference between the best individual position and the previous position plus the social weight multiplied by R2 multiplied by the difference between the best overall position and the previous position. And the new position will be calculated with this formula. The new speed that we calculated here and the previous position. In the next lecture, we are going to see how we can represent the particles and the population.